We are continuing with Euclidean. So as you can see, we have information E that we have to work on. So information E, on the following sketch, sinama circles are 2, okay, that they are touching each other at a point kabane kathina ngintila, but I hope you can see it. There is T. O is the center of the smaller circle. The smaller circle has a center, so we're gonna make use of that. And then circle, okay, BTE and ATF are straight lines. Okay, cool, fine. Now they are asking us to determine with reasons the size of T2. Where is T2? Let's go and identify where is T2. There is T2. There is T2. What is it? Do we have a cyclic quad? Yes, we do have. We have 2 cyclic quads. We have cyclic quad A, C, D, T, and cyclic quad C, B, T, D. So, but where does this line BE fall? Where does this line add up to to form a cyclic quad? So it's adding up on which cyclic quad? It's adding up on cyclic quad C, D, T, B. Exactly. Yeah, that's why it's adding up to form a cyclic quad. So an exterior angle is gonna be for that one. So exterior angle T2, which is T2, is gonna be equal to an opposite interior angle of which it's 70 degrees. I hope that is clear though, because this is a straight line. This is a straight line, and then we have an exterior angle here. I hope you can see that. Fine. So which means T2, angle T2 is equal to angle C, angle BC. Okay, let me name it properly. Angle B. What's happening now? Angle B, angle BC. D, which is equal to 70 degrees. The reason behind that, exterior angle of cyclic quad no, this is wrong. Cyclic, it's CY, cyclic quad. Yes, yeah, cyclic quad. Okay. Now we know T2. Now let's go for O1. Where is O1? O1 is the angle at the center for the smaller circle. Okay, it's the angle at the center for the smaller circle. How are we going to get to that? Okay, T1 is going to help us. But do we have a value for T1? No, we don't have. But T1 is vertically opposite towards T4. Do we have a value for T4? No, we don't have it yet. But we can have it because angle T4 and angle ACB, they are equal. Angles on the same segment. Let's go for that. Angle T4 is equal to angle ACB, and they are equal to 40. How come? It's because angles in same seg. Right. So now we have a 40 here. 40 is equal to T1. So T1 is equal to T4, and they are equal to 40. What's the reasoning behind that? Vertically opposite angles. Alright, now let's conclude. Now, angle at the center is twice the angle at the circumference. What does that mean? That means T1 is half O1. So in order to get O1, you're going to have to times 2. So O1 is equal to 2 times T1, of which it's 40. We can just put 40 there, and then we're going to be having 80 degrees. Just like that. We're done. Right, let's go for another one. Let's go for another one. Let's go for another one. Hey boom. Let's just go for another one. Right, so what do we have here? Now we have more details. Okay, we have a tangent. Okay, we have a diameter, and then we have parallel lines. Oh my god! And then we have 52 degrees. Okay, it's fine. We have seen or we got to read the information. Now we know what is happening here. They're asking us about P1. What is P1? Okay, let me enlarge this thing so we can clearly see. What is P1? Is P1 angle at the center? Yes, it's at the center, but it's around the point actually, not really there. So, but how can we get P1? Oh, P1, we can get P1. Remember, D1 is 90 degrees, but we have to say something that is going to make D1 equal to 90 degrees. Let's say it. D1 is equal to 90 degrees. Why? It's radi perpendicular to tangent. Because tangent is CF. They did tell us that CF, CDF is a tangent. And then we have a line drawn from center, which is PD, that is perpendicular to it. So now we do have a 90 degrees angle because of that. So P1 is going to be what? We're going to get P1 due to sum of angles of a triangle. So P1, we advanced now. We advanced. So we're just going to say P1 is equal to 180 minus 52 degrees minus 90 degrees. The reasoning behind this was, but you ain't supposed to write the reasoning on this one. But I'm just gonna be writing it. But you should write the reasoning next to where you are saying P1 plus angle C plus D1 equal to 180. That's when you can say angles sum of angles of a triangle. But I'm just gonna say it now. Sum of angles in triangle. Okay. All right, and then 180 minus 52 minus what? Let me bring out my calculator. 180 minus 52 minus 90, that is 38 degrees. So P1 is equal to 38 degrees. Now let's go for angle A1. What is A1? P1 is equal to 38, so we do not forget, because maybe we're going to use it, and then whatever that you have worked out on the previous question, you might use it on the following questions. So now they're asking us about D1. What is D1? A1, oh, an angle between a tangent. There is a tangent. What is tangent? It's EAG is a tangent, and the chord AB. Angle between a tangent and the chord is equal to an angle subtended by the same chord. Which angle is subtended by the same chord? That is D2. Can we get D2? Exactly, we can, because we have parallel lines that we haven't used. So D2 is equal to P1, and they are equal to 38 degrees. 38 degrees. How come? It's alternating angles. Why are they alternating? It's because CP is parallel to DA. I let DA. No, not that DA, not that one. No. Nope. So now A1 is gonna be equal to D. Now A1 is gonna be equal to D2. And they are equal to 38 degrees. Why? It's tan chord theorem. So it's tan chord theorem. Okay, now let's go for angle B. Where is angle B? First thing first, go and highlight where is angle B, and then what is it that has to do with angle B? What are the characteristics of angle B? Where is angle B? Let's go and check. Angle B is up there. Oh, there is angle B. All right, how can we get angle B? Now we know this one is 38. Okay, and then do we have a second? No, we don't have it. We have 90 degrees here. Do we have A2? Now we don't have A2, because this was going to be easy, because we're going to use sum of angles of a triangle. Oh, we do have A2. We do have it. A2 is equal to 90 degrees. Why? It's subtended by diameter. Let's go. A2, angle A2 You see how to identify the things. Come on, man. A2 is equal to 90 degrees. Why? It's angle in semicircle. Angle in semicircle. Now we do have this one as 90 degrees. Can we work out angle P? Yes, sum of angles of a triangle. I don't even have to calculate that one for you. You can do it on your own. Homework yako. Alright, thank you for watching.